Good morning or afternoon, everyone, and thank you for joining us for today's webinar, Using Data Science for Anomaly Detection. We're really excited to have with us Taylor McCaslin. Taylor is a data science product manager and has created multiple products that use data science at their core. He's a longtime customer of both Snowflake and Zepl, and he will share his experience on how he turns business data into business value. He's worked for several enterprise-scale hyper-growth tech companies, including WP Engine, Duo Security, and Cisco. We also have with us Josh Chacona, sales engineer with Snowflake, and Zach Shainski, solution architect with Zepl. And also joining us is Dave Marina from SSIT, our system integrator partner. And thanks to SSIT for creating the notebook that you will see in today's demo. You will automatically receive a recording of this webinar within 24 hours, and we have time at the end for an awesome Q&A with our team, so please submit your questions in the chat box. And with that, I will hand it over to Taylor.
Hi, everyone. My name is Taylor McCaslin, and today I am going to take you through an introduction to data science and using it for anomaly detection with Snowflake and Zepl. So on our agenda today, we're going to talk about what it means to have a data science mindset, some of the challenges that are frequently encountered by organizations in their data science ambitions, and then take a look at how you can start using data science to do anomaly detection within your businesses. We'll also take a look at a reference architecture that may be of use to you, and then do product demos using Snowflake and Zepl together. So to get us started, I want to talk a little bit about business intelligence and the move towards data science. So business intelligence today, you very likely have business intel people within your organizations in some analytics or customer success role. This is very common. Most organizations have it today. And what they're really doing is helping the business understand why certain things are happening. It's about looking at data and making conclusions. It's a very looking back focus for most organizations. And what can end up being a trap is that your business intelligence people end up only answering questions about when something happens, not necessarily about why something happens. And that's really where we're starting to see data science go, is to look at larger pictures about not just when something happens, but why it happens and what you might go and do about it. So that really is sort of the trend that we're seeing for business intelligence moving into data science. It really is that shift of looking forward and making decisions and changing what you do in the future, rather than looking back to understand what did happen. And as we all know, we're in a unique situation now with the global pandemic of COVID-19. Our businesses are changing in bizarre and unusual ways very rapidly. And this is one where if you have a more mature business intelligence team or even a data science team, you're able to start looking at how your businesses are shifting earlier and faster. So that's a trend that we're seeing now. And I think this is one where we're going from analytics to intelligence, and it's a real piece where we have to look at what problems and challenges do we have as businesses as we're trying to adapt to this new reality where things just change a lot faster than they used to. So let's take a look at some of the challenges that you have as you start maturing your data practices from analytics really into intelligence. And the first one being that a lot of organizations don't truly understand what data science is. It's one where it's really easy to assume that data science is this magic black box that will that will give you magical answers or create value. We've all seen the jokes about data science creating 10x multiples on organizations. But in reality, that's not really what data science is about. It's about using data and math and statistics to make decisions in real time. So it's one where I see this a lot in organizations where either they don't have data science leadership or they're just getting started with data science. They don't quite know exactly what it means. So you really do need people internally to understand what is data science and what are we trying to accomplish with it within our organization. The next challenge that I see a lot is that there's a struggle to measure impact and translate value of data science. It's one where data scientists are expensive resources for most companies. They come at a premium, and it can be very hard to justify that spend on what people are actually doing with data science. And it's one where, again, this ties back to that previous issue where if you don't have a strong sense of what you're trying to accomplish with data science within your organization, or even what the realities of your data is within your company, you can really fall into this trap of not knowing how to measure data science. The next one that I see a lot is it's really easy for data science groups to fall into a trap where business leaders don't trust the data or the insights coming out of those systems. It's one where you really need to get your stakeholders involved with the formation of the models, running their actual customers' data or real-time data through these models so that you can really understand what's happening as you look at those and gain trust within an organization and your data science practices. This is one where I see that if I can get my stakeholders directly involved with interacting with the data products that my data science teams are creating, I can get them to understand what we're trying to accomplish and give us a lot of valuable feedback very quickly. And so it's one where this is the value proposition of where Snowflake and Zepl really shine, is that you can bring in your live production data as it's coming through your data warehouse like Snowflake, and then actually do real-time processing on it with advanced data science models in a platform like Zepl. And doing that in a place where you can have non-technical people interact with those is really, really important. Another challenge that we have, which I think gets discounted a lot, is just the technical infrastructure problems that come along with data science. Data science is in many cases a DevOps problem where you need a very technical infrastructure that has very unique requirements that in many cases businesses aren't well suited to be able to manage and maintain. So it's one where you've got to ask the question of, am I even ready to do data science? Do I have confidence in my data? Do I trust the data? Is the data in the right place? Is it in the right shape? Do I have the right business logic within that data? And all of that has to happen before I can ever really start to do any real data science work. So it's a tricky area to really get right. So these are a few of the challenges that I commonly see a lot of organizations face as they're starting to adapt a data science mindset. So we'll talk through how to address a number of these in today's webinar. So this is where I think anomaly detection is a really interesting starting place for an organization wanting to start doing more data science and really advancing the way that they're using their business intel people. And this is one where what's nice about anomaly detection is no matter what industry or product that you create or have, your business likely has some business problem that would gain value from something like anomaly detection. And what I like about anomaly detection is it's a very easy concept for people to understand. Just about anyone, technical or non, can look at a graph and say, hey, there's a weird point on there. Why did it spike? Why did it go down rapidly? So it's a really easy thing for people to think about. The other nice part is that anomaly detection is a really, really large field of study. You can do everything from very, very simple statistics all the way to advanced ML and AI models to do prediction on top of time series data. So I like it because no matter where or how mature you are as an organization with your data science capabilities, there's something for everyone there. So I think it's a really great place to start. And then this is one where you can get to value very quickly with anomaly detection. Just about every business wants to understand how sales projections work, or what to do when your sales dip, or when there's a weird anomaly in your data. So it's really easy to go and get value from something like anomaly detection very quickly. So let's look at a few use cases that I've seen with anomaly detection. The first one being fraud. This is a very common example of using anomaly detection in a business context, really looking for inauthentic behavior or abuse of your services so that you can kick off those abusers from your platform and really protect your business. If you think about it, fraud really is just an anomaly in your data set. If you can detect it, you can then mitigate it. The next one is financial ambitions. This is where just about every business has some form of seasonality, whether that's month to month or dealing with annual holiday seasons. Seasonality is a tricky thing, as any business intelligence person knows, to adapt and accommodate data. This is one where using a little bit more advanced system like an anomaly detection piece can help you really understand when something is seasonal or when something is very bizarre in the moment. You see an example here to the right of a particular analysis that I like to use, which is called STL decomposition, which basically is looking at data that we know have trends in it. It's one where in that top graph, it can be really hard to understand that there might be anomalies in that data. But as you process that with something like STL decomposition, you can really make that super clear for someone to really see in a different way how that data is anomalous. Other ways that I've seen this done are looking at things like customer success, looking at health scores and predicting customer churn. If you have that kind of data, this can be a really valuable proposition where you can leverage anomalies within your customer success data to detect before some customer churns, so that you have a chance to step in and really remediate that. The next would be cybersecurity. It's honestly an endless field of study to do things like intrusion detection, data leaks, and all sorts of other cybersecurity related anomaly detection. And these are just a few of the common cases that I've seen. Certainly just about any industry would value from some form of anomaly detection. So it's why I think it's a great place to start. And when we look at anomaly detection, there's so much that you can actually do with it. The number of libraries, the languages, the packages that you can use to go and power these anomaly detection pieces is really complex. And it's one where, regardless of what you're trying to accomplish, there's a lot that you have to think about. And this is in crux sort of the problem that we're talking about today is, how do I go and do something really simple with data science that is anomaly detection and navigate this complex world of lots of different libraries, different languages, throwing in your data realities into that? How can you reconcile all of those things so that you can focus on creating value for your business? And that really is what today's talk is about how do we leverage all of these data science tools in a singular place on top of your live production data to be able to really get to value faster. And so let's talk a little bit about what that data science architecture might look like. This is a framework that I've used at a number of companies, basically building a modern data science pipeline where wherever your data may happen to live in your organization, pulling that data into a centralized place like Snowflake, a data warehouse where you can then start using ETL processes to shape and incorporate business logic so that you're able to do very clean data analysis on top of all of your production data, is a big core problem. You'll hear a lot of data scientists talk about, I'm just stuck doing data engineering tasks a lot. And this is one of the reasons I like Snowflake, is because it makes a lot of those problems a lot easier to deal with. And then you've got a very consistent interface to interact with your product or your business data and connect it to any sort of analysis source. Then this is where I connect Zepl with Snowflake. And I discovered Zepl a few years ago because of their native Snowflake connection. So it's very easy to connect to a live data source within Snowflake and pull that data into a platform like Zepl, where you can then start working in notebooks to run analysis and really explain what you're doing with that data. And the fact that these platforms both talk to each other and allow you to integrate securely with each other, that is the real piece where I can let my data scientists focus on working with the data and doing actual data science rather than worrying about all of the data processing and all of the data infrastructure issues that come along with a modern data science practice. So this is a pattern that I've seen work really well. It's why I love Snowflake and Zepl. And to talk a little bit more of that, I'll introduce one of our friends from Snowflake who can talk you through leveraging data science on top of the Snowflake platform, and then we'll give a demo of Zepl. So I'll hand it off now to Josh, who's a sales engineer at Snowflake.
Excellent, thank you very much. With Snowflake, we've working with customers in the data science realm, we've uncovered some key requirements for data science that really are needed for a successful deployment of models and really to gain valuable insight across all lines of business. Number one, organizations need to be able to collect and organize data from a variety of sources before they can analyze it. The more data points they are able to collect, the more accurate their analysis will be. The computing power is required to run the algorithms that analyze the data, and modern systems can process billions of operations every second. That allows for analysis far beyond the computational capacity of humans. There are many new algorithms, models, and frameworks and tools that are coming out each year to stay ahead, and you want to be able to use any and all of them at any point in time across a single source of data. Analytics processes generate enriched data that can then be fed into additional processes, and this cycle results in highly advanced iterative processes that continue to combine human intellect and computer-driven analysis. Now, with Snowflake, we've created the first cloud data platform that delivers the performance, the scalability, and concurrency required to allow you to finally address your most demanding data-related challenges. The journey has seemed incremental and as steps along the way, but none have been fully delivered beyond meeting the ease of use, scale, and performance that is needed to support today's workloads. The desire for analytics has grown so much that it's often become difficult to support the multitude of concurrent workloads, all users demanding the same single source of truth in a modern enterprise. Even big data solutions such as Hadoop and data lake, object stores, solve part of this problem by making it possible to handle both structured and semi-structured data, but partially address the problem of getting many users to the platform. The Snowflake Cloud Data Platform is the first solution that brings the best of on-premise EDWs to the cloud, along with the big data solutions into a single platform that delivers the scale, the performance, and the concurrency all of its predecessors failed to do. So with data science, most of the customers that I've worked with that have mature data science teams have implemented a workflow similar to this. For each business problem they're trying to solve, they often first identify the data sets that can be helpful. These data sets might be first-party or third-party data sets brought to them. Next, they manually try to visualize and understand the data. They see the patterns that exist and what features and attributes might be helpful. And this happens at almost every step of the process. Then they clean up the data and transform it and perform feature engineering against it, where they will try to create new features from existing ones or reformat existing features. Next up is where this data is used to train a machine learning model. This is an automated step which is computationally intensive. Once this model is trained, the model is saved for batch prediction or deployed as part of an API to do real-time predictions or inference. And finally, each model is then monitored and evaluated as to how it performs with production data over time. Now let's see how Snowflake fits into this workflow. First, let's look at the platform features that help throughout the data science workflow. Data science needs massive amounts of data sets. Snowflake provides cost-effective storage for data science data sets. Role-based access control within Snowflake ensures that the right team members have the right access to the right data sets without needing to involve cloud infrastructure team members or other IT personnel. Data in Snowflake can be replicated across regions or across clouds using Snowflake Replication Service. And this instant scalability also ensures the data science team can finish their work in time without affecting other production workloads. And finally, Snowflake being a managed service means that customers don't have to worry about managing any other kind of infrastructure. It's as close to a data platform as a service as you could possibly be without restricting all configuration. Data science at scale requires transformation and feature engineering to be implemented as pipelines. These transformations, such as aggregation, feature label encoding, et cetera, can be easily implemented as SQL using streams and tasks within Snowflake. Snowflake external functions can also be leveraged to enrich data from external APIs and also provide a method to perform batch inference against an ML model deployed outside of Snowflake. Having a separate copy of your data for each experiment and/or data scientist can enable agility and quick experimentation. Zero-copy cloning in Snowflake enables an efficient way to store and distribute multiple copies of the same data set. Now, once the data is ready, it can be used with Zepl to train the machine learning model. The training and deployment of the model does not happen within Snowflake. We've partnered with Zepl so that we can enable our customers to leverage the best breed of both platforms with the most cutting-edge ML libraries. And finally, as the world changes around us, we want to enable the accuracy of those models to be trained on older data. As it may change over time, this is often called model drift. Mature data science implementations build mechanisms to monitor the performance of their models in production to keep a check on model drift and to determine when it's time to retrain the model with the new data. So with Snowflake, it's super easy to persist prediction and build dashboards that let you evaluate the performance by comparing predictions to the ground truth. So with that, I'll go ahead and hand over the reins to Zach, our Zepl solutions engineer, to perform the demo with Snowflake and Zepl.
Great. Thanks, Josh. Appreciate that. Taylor, thank you. You guys set a really great foundation for what we're going to jump into next, which is how do we take this concept of fraud or an anomaly detection use case with a really large data set inside of Snowflake and empower your data science team to be able to actually get some meaningful insight from all of that data. So what I want to walk you through here is exactly that, a scenario where we've got transaction data and it's been labeled as fraudulent or non-fraudulent transactions. And I'm going to use Zepl as a way to talk about the secure connection to Snowflake that we provide. We'll walk through Zepl as a data science platform. So sure, it's a place, one to get your work done in a notebook type environment, but also how do you enable people in your team, both technical and non-technical users, to consume the reports and the models that you're building. Ultimately, we'll finish up and we'll talk about the resources behind the scenes that power all the analysis within inside of Zepl, and then I'll show you some really nice examples of how visualizations can be both interactive or your out of the box or your standard libraries that you're used to using as far as data science. So let me go ahead and pull up my screen here, and we'll jump right in. Great. So how do you get started with Zepl? How do I get access to a free trial of Zepl? There's two ways. One is through your Snowflake account. If you go up to Partner Connect, you can easily spin up a free trial of Zepl here. It will automatically create a free instance for you. You'll be able to create a username, log in, and get started with an instant connection to Snowflake. I said there's two ways. So the other way is just going through Zepl's website, zepl.com, sign up for a free trial, and you can always connect into Snowflake at any point. So once you sign up and get started, you will have access to all the tools and features that I'm about to show you here within Zepl. So since we're a SaaS-based product, the first thing that you're going to want to do is connect to Snowflake or connect to your data source. So let me show you what that looks like. I'm sharing with you a notebook here on the screen that I've done some work around a fraud detection use case and building a model. And this data source that I've created called Anomaly detection is a Snowflake data connection. So when you come through Partner Connect, we'll automatically create one of these data source connections for you. If you come through our website, you can always create as many of these as you want through any mechanism. And it's really quite simple. You just put in your account, warehouse, database, and/or schema, and you're off to the races. Now, why am I starting here and showing you this? Well, one of the value adds of having a data source concept that we've built into Zepl is the ability to put your username and password, or if you're using single sign-on to authenticate into Snowflake or wherever your data resides, we can support that as well. So that's a really nice feature to be able to abstract away any credentials that you otherwise might be writing in your code and in your notebooks, risking a potential breach of your credentials that may get committed back to a central repository or something like that. So we feel like this approach is a really strong and secure way to connect to any data source. So that's how you connect to Snowflake. And of course, all the data that we have for this example is in Snowflake, but you may want to have other data connections. And so just to call a few of those out, wherever your data lives, we can connect to it in this secure manner. If it's a standard JDBC connection, we can connect to that too. And here are a sample or a flavor of a few of the ways that we can securely connect to different data sources. Great. So we've set up our first connection to Snowflake. We've securely stored our username and password. And if any other users try to access this same data set, and maybe they don't have the right credentials or the right level of access in the backend system like Snowflake, they won't be able to access that data. So you can be sure that the data privacy or the data governance rules that you've set up where your data lives will be preserved. So the next thing in this notebook that we'll need to do as far as setup is importing libraries. So I've got a number of standard libraries that we've prepackaged and delivered to all of the notebooks or exposed to all the notebooks inside of Zepl. So you'll see some common libraries like pandas, Seaborn, Matplotlib, NumPy, scikit-learn, and for a handful up to 50 different libraries, we've prepackaged images and handled all the dependencies. So your data scientists can have, or the team can have, the exact same experience running my code, running your code, all within this platform. You don't have to spend time with that configuration step. Of course, if there's external libraries that you want to install, you can really easily use package managers like pip. I'm sharing a lot of code here in Python, but we can also run Spark on the back end using Scala to interface with that, or you might be using R as well, or even just directly querying data sets through SQL. So we can support multiple languages running all within the same notebook. So within this analysis, I wanted to provide more of a dashboard-like feel to my users. And so I've created a few different inputs here at the very top. I want to specify what data table people are able to connect to, what data source that they should be connecting to, and then take those inputs and use them in my data, use them in my notebook and in my code here. So you'll notice that when I make this connection to Snowflake, there's only one line of code that's required. There's a library we've created called zdot, and it's this context that gives any language you might be writing inside of Zepl, or any data source you might be connecting to inside of Zepl. It creates a standard way to connect to it with just one single line of code, which is really nice because you might have different types of connection strings, and you might have to reference that documentation a lot. This is just one single line of code for any data source that you might be connecting to get you up and running really quickly. Then I just execute a simple select statement from Snowflake, and ultimately we're able to visualize what this data looks like. So now we've got our data into Zepl, and we're ready to start visualizing it and taking it through that pipeline that Josh described as far as visualization, feature engineering, model building, training, and testing, and then ultimately scoring and improving upon it. So we'll walk through those different steps. Again, I'm showing another example of how we provide another standard function, our standard library, to visualize data in this case, where you can take a data frame and just write this one command called z.show, which allows you to then select through a lot of different interactive charts that are built into Zepl. I'll show you a few examples of those as we go down, but just quickly take note of what the data is that we have here. It's payment, different types of payment transactions, the amount, what the originating balance was, and the destination, how money was transferred, and then ultimately our data is labeled as fraud or not fraud. So from here, let's look at a few visualizations. We clean up our data, we look at a few null values, and then we start to visualize things like what type of values are we getting and what percentage. If I drill down on this graph and look at my transferred types, how many of those transfers were labeled as fraudulent and how many were labeled as non-fraudulent? So some pretty nice interactive ways that you can work with this data. We have a lot of interactive charts built in, and a really nice editor for you to use this drag and drop interface. And again, data scientists, you might be the kind of person that loves to create your matplotlib type charts, right? That back-end Python library or library-based visualizations, we can definitely support that. But as you start to share out these reports with other parts of the business or non-technical users, you can start to expose a lot more interactivity within your notebook so that people can be empowered to manipulate the same data sets. So I'm going to scroll down here. We're comparing different features around fraudulent and non-fraudulent transactions. One thing that I want to call out is this chart down here. There's an insane number of false versus true. Is it fraud or is it not fraud? So, of course, most transactions are not fraud. A very, very small number are. And one of the values of having a platform like Zepl is exposing really easily, or giving access really easily to a lot of libraries that are built in to let you handle this training or data manipulation step. So what we're going to do now is we're going to balance our data because it's pretty skewed, and that's called oversampling. And once we do that, then we can train and test our model and then ultimately get a prediction out of the other side. Before we do that, I think it would be good to call out, where is this code running? How is this executing? So Zepl is built on a containerized environment where each notebook will have its own container attached. And the value of this is that, one, it spins up extremely fast. So, and then two, there's very little configuration involved. And finally, if you do need to configure anything, let's take resources, for example. Maybe you have, right here, I'm showing that I'm using a standard 8 GB, general compute instance. But if I needed to scale that up or scale that down, depending on the workload that I'm using, we make it really easy to do that and give your team the access that they need without having to spend a lot of cycles, maybe putting in requests or putting in tickets with IT or engineering to provision more resources or hardware. And then ultimately behind the scenes, we'll attach an image which has all of the libraries that you need to work with, and you're off to the races, and everyone has the same standard experience. So coming back to this model that we're building, I said we're going to balance out our data set. So you can see we're performing this oversampling. We're showing that it's very skewed number of columns that we're working with here. And after oversampling, we have a very balanced data set. And that's important for this fraudulent type use case that we're having to deal with. I've hidden one of the cells here for the fitting, training, scaling of our data, but ultimately I'll hide this just and say that step we actually train our model, and then the output we're visualizing here for accuracy as well as model loss, and ultimately what are our precision or recall metrics for this model, right? How do we make sure that our false positives and our true positives are being exposed? And then lastly, what is the accuracy of what we're predicting. Great. So let me go ahead and pause there and sort of recap. We started with a secure connection into Snowflake. We evaluated what our data looked like, observed that there was definitely a skew, and then we tried to improve upon that skew by oversampling and ultimately coming out with a model trained and with a prediction level of accuracy. The next step that you might want to do is probably one of two things or both. You probably want to share out your findings with other members of your team. So inside of Zepl, it's not just a notebook interface. It's really important to have a collaboration aspect or be able to share results and findings with both technical and non-technical users. And so we've created this sharing mechanism. So anyone can come in and select a user or select a team or share with an entire organization different levels of access for this notebook. You can see here, if I want to give Elise access to this notebook, maybe I want her to have read-only permissions. But then I might want to have a different user to have like Dan Maloney, our CEO. He might need to have the ability to clone this notebook and then take that off and iterate on it and take another revision or another stab at the model that I've built based off of the exact same data set. So we're able to provide a lot of access, collaboration, and management controls there. And then the next thing that you might want to do is share these individual findings either internally or externally. So you can share individual paragraphs in the results here based off of a given paragraph link. You can share the entire notebook here if you wanted to publish it and make it public to anybody to see. Then we have that option as well. And then finally, there's this concept that as we're iterating on this notebook, we're writing new code and we're clicking run for each different paragraph. We're maybe getting different results or different levels of accuracy. Well, it's important to be able to version control not just code, but also the result set. So you have a history or timeline or some lineage of where the model started, and the improvements as you keep working on it. So we have a concept of version control where we're automatically versioning both code revisions as well as result set changes. And then of course you can always make your own commits here. So maybe this is my stable build that I want people to revert back to and be able to clone this notebook from. Okay. So with that, I think that I'll take a pause and bring it back to Elise or to the slides here, and we can open this up for questions.
Great, thank you so much. Let me get to my panel here. Great, and by way of next steps, if you are interested in learning more about how to use Zepl and Snowflake for anomaly detection, we have a free guided trial. And if you just want to contact Zach, what he can do is work with you and your team to evaluate your specific use case, give you some training on the solution, kind of get you up and running, and support you through a guided trial to evaluate the product. So we do have a few questions, and if you would like to submit some more, please feel free to. So one is, let's see, this is for Zach. Where is the code for each notebook stored so we can share it across multiple people?
Yeah, great question. So all of the code, as you saw, those different commits or different versions, it is getting stored on the Zepl platform. And then there's a number of different ways or mechanisms to collaborate and share. One is, like I showed you, is internally. Maybe actually I can share an example of this if I bring my screen back up kind of prematurely. Shut it down there. But so what I'm showing you here is a notebook an individual notebook, right? But where we logically group everything together in this interactive space is if I go to the home page of Zepl, you'll see all of the notebooks that you have access to or that people have shared with you in a few different places. One is within your recent work, and two is within this concept called spaces. So you can think of a space as something that's an interactive folder, which anyone that has access to it, if I drill down on this one, samples and experiments, you'll see that 45 people have access based off of these access controls and permissions for all of the notebooks in this space. So, that's how we group together different code and notebooks that get created and how you're able to share them. And I hope that answers your question a little bit better, gives some context outside of just the notebook that I was showing you there.
I'll jump in here too. Like, this is the real value proposition from my perspective of a platform like Zepl running on top of Snowflake data, is that when you have non-technical business owners who maybe your data science or your business intelligence teams go off and create these notebooks and analysis, today, a lot of that analysis ends up happening on those people's individual laptops. You have to ask them to go and run the data analysis on whatever data you're interested in. With a platform like Zepl, you're able to have these shared notebooks where you can have, let's say, like sales projection notebook or a data deep dive notebook where anyone can come in, and because you pre-configure the analysis, you can set up those notebooks to be very explicit and explanatory on what they're doing. And because you've got the data already connected, it's really easy for anyone non-technically to come in and to run these notebooks at any time. Or, as Zach showed, to go back and reference previous version histories to see previous runs of that data that someone has done. One of my favorite things actually is being able to name those versions so that you can quickly look back and go into a particular analysis historically and actually see the flow through of the analysis. From my perspective as a data science product manager, that is a really huge value because it allows me to not need to spin up a data science environment on my machine. It makes me be able to interpret and process the models and the analysis that my data scientists are doing anytime I choose, whether it's 2 a.m. or on a Saturday. So it's one where analysis, I know one of the things we did previously at one of my companies was anybody would just copy these notebooks to quickly have a working spot rather than starting from zero every single time. And the value of all of that together is just really huge to be able to create a platform where you can go and look for analysis and you know that all of your work is in this centralized place.
Great. Thank you for that. And Taylor, anything else from you, Zach?
No, I appreciate the comment, Taylor. That's great.
And then I actually have a question here for Taylor. So somebody said, so it seems like this platform is similar to Jupyter Hub, but with additional interactive capabilities for supporting better visualizations and easy sharing with stakeholders. And Taylor, I know you have some firsthand experience with Jupyter Hub. Do you kind of want to answer that?
Yeah, so it's funny. I mean, I've used Jupyter Hub previously. In fact, that's what we used before we moved to Zepl. And it's one where, again, because that's a hosted environment that's very specific to your data scientists, it's hard for a non-technical person to come in and interact with those notebooks. And then we were doing really terrible things like embedding Snowflake credentials into those notebooks directly. Jupyter Hub at the time didn't have any way to securely connect to data the way that Zepl does. So we moved away from Jupyter Hub. We also were doing very advanced data analysis. We had large-scale AI models that we were running, which would take huge machines. And what would end up happening, we had a data science team of about 12 people, and we would go off and run analysis. And let's say that we tried to process through 1 million data objects. We would very easily knock over our Jupyter Hub instance. And it would be one where we would break for the day until someone from DevOps could come and help spin the environment back up that we had knocked over. So it's one where the aspect that with Zepl, each one of your notebooks runs in a siloed container that you can provision the necessary resources for. It's a way to do cost management. It's a way to break apart that dependency so that every notebook lives inside its own little container, so that if I'm doing some crazy large analysis that requires a big beefy machine, I can only spin that up when I'm doing that analysis. And if I happen to break something or knock that over with my analysis, it doesn't affect anything else that anyone else is doing. So from my perspective, like that's thinking of it as like a more modern version of Jupyter Hub is exactly correct. And then with the built-in sharing capabilities and the ability to annotate and to have all of my analysis in a single place, like it just made it an obvious answer for us to really bring together our technical and non-technical folks.
Awesome, thank you. Question here for Dave Marino with SSIT. How do we migrate from other data science platforms into Zepl? Will SSIT and Zepl help us in that migration exercise?
Well, that's a great question. Yes, that's actually one of the areas of focus of SSIT is helping take a look at your existing environment and your data sources, potentially your data warehouse and your existing data science platforms that you're using and migrating it over. So yes, that's not a problem. If you have questions on that, you can reach out to Zach and we'll get in touch with you. Thank you for the question.
Great. Zach, we've got a couple questions about AutoML. Can you explain how Zepl works with, well, first the difference between manual ML and AutoML, and then how Zepl works with both of those?
Yeah, great questions. So the manual ML process is something that everyone is going to need to do in some level of their pipeline. And it was the example that I just shared with everybody walking through that notebook was an example of using manual machine learning. Now there's this concept of auto ML, which is commonly used in conjunction with manual ML, and something that in Zepl we support really well. So a lot of the AutoML providers will have libraries that you can import, just the same as we did with any of those imported libraries like scikit-learn and NumPy. And you can run your analysis or your AutoML libraries right inside of your notebook to then get your results back for the best models to run. And then ultimately, as you need to tweak those, you can continue to use the notebook interface to iterate upon them. And then it also gives a nice way. Zepl continues to give a nice way in that regard to share what is the result of your AutoML process that was run, and how should the team move forward for selecting a specific model that works best with their data.
Awesome, thank you. We have a couple questions around Jupyter, Zach. So one is, can I get rid of Jupyter completely if I get Zepl? And can it perform all the Jupyter capabilities? As well as, I have a lot of Jupyter and Zepl notebooks. What do I do with those? Can I use those in Zepl? Sort of how does Zepl work with Jupyter and Apache Zepl notebooks?
Yeah, great question. I think I'll answer part of that and then have Taylor answer the rest, because he has the real world experience and I think was just touching on that question. But if you have existing work, which we assume most all enterprises do in the same way that that Taylor described, right? You probably have a bunch of notebooks or code that's written on a bunch laptops that are dispersed around your company, or maybe you have a number of notebooks that are committed to a central Git repository. Whatever it is, if you have any notebooks, we can bring them into Zepl, and you can start to run on top of Zepl that existing work that you've already done. So make it, we want to make it really easy, and we understand that everyone has a lot of existing work in these notebook solutions that are out there, and you can really easily import those into Zepl. And then there was another part of the question: can you fully replace some of these open source notebooking solutions. I think, Taylor, if you wouldn't mind commenting on that, I think you already did touch on it, but it might be good to just drive the point home as far as your experience.
Sure. So I'll actually tell a little story here. So my previous job was at a large, basically social listening platform where we were ingesting large quantities of social media data and then doing ML and AI processing of that data to do things like topic modeling, time series analysis, and anomaly detection. It was one where a particular thing went viral on a Saturday night. We all sort of spun up. We had like a war room in Zoom at 2 a.m. and our data scientists who had been running that analysis for us had their Jupyter notebook on their machine at home, and they had already gone to bed for the evening. So it was one where I needed immediate access to some of the advanced models that we had created, but we didn't have them shared anywhere. We did have a GitHub repository where we were pushing those notebooks to be version controlled, but it was still a place where, because she had directly connected with data on her machine, I didn't have a way to spin that notebook up, replicate the data connections she had. She had been doing offline data processing. So it was this sort of nightmare scenario where we didn't have a way to spin up the intelligence that we had created with our data science models when we needed them most. And that, frankly, was one of the primary reasons we started looking for an alternative to Jupyter Hub. We needed something that was a cloud environment that connected directly to our Snowflake data warehouse and allowed anybody in the organization to run any of the analysis that we had put together. And it got to the point where, because our data pipeline was built solely on top of Snowflake, we put all of our business logic within Snowflake. We had a very clean interface to pull in data from very specific data science tables that we created, which were actually views on top of our data in Snowflake. And we would run that analysis within those Zepl notebooks, and then we would actually push that data back into Snowflake as a data product. And creating that whole process really was how we were able to really speed up the way that we were doing our analysis. Rather than waiting for a data scientist to go and process a request, instead me as a non-technical person could log into Zepl, click a drop down of the date range I was interested in and the data product that I was wanting to run on top of, and then run an analysis without needing to know anything specific about what the analysis was doing. And that for us like completely changed the game, to the point where we even had non-technical customer success people running notebooks on their own. So our data scientists really were focused on just creating the initial versions of our models, putting them into notebooks with drop-downs and with input fields that non-technical people could quickly fill out and then run those notebooks. So yeah, I mean, we completely replaced all of our Jupyter Hub, all of our local notebooks, and moved everything into Zepl. And that was where our data scientists did all of their work.
Great, Taylor. Thanks so much for that. Question for Josh. How does Snowflake handle unstructured data like large engineering machine log files, AV-based AI ML? What's the process of loading, processing, and model building? Basically trying to understand how Snowflake helps to analyze unstructured big data.
Yeah, definitely. Great question. So in terms of log files, we treat semi-structured data, so JSON, Parquet, ORC, et cetera, as first-class citizens in a SQL world. We have a variant data type that ingests, and essentially you can insert that data into a Snowflake table in its native format and then query against it using SQL extension. For unstructured data, such as audio and video files, those are often kept in S3 buckets, and the metadata associated with those files is then queried against Snowflake. We're using Snowflake. Additionally, we have on our roadmap I'm sorry?
Nope, go ahead, Josh.
Okay. Yeah, on our roadmap, we do have additional support for unstructured data in terms of managing the access to that from a multi-cloud approach. So there are some exciting developments rolling out over the next 6 weeks. But as of now, that is the best method of leveraging Snowflake for unstructured data.
I'll jump in here as well. We did exactly this use case at my previous company where with that, we would ingest about 50 million unique pieces of social media content every day. And we had tons of scrapers that were pulling those in JSON formats. And it was extremely nice to be able to ingest those into Snowflake, run an ETL process to normalize that data. And for me to not need to know anything about how that system was working, and instead being able to query that data directly within Snowflake and Zepl just using standard SQL. So I've seen that platform work in terms of ingesting large amounts of data and normalizing that. And that for me is one of my favorite aspects of Snowflake. We also would have S3 buckets of various media that was associated with those social media posts. And so it was one where you could query directly for those individual pieces and then reference from the data buckets for like the images or videos associated with it. It's a pretty seamless process that really allowed us to focus a lot more on the actual analysis rather than the data engineering of just getting your data into the right format.
Great, thanks. We have one more question, which is for Zach. It could be actually for Zach and Taylor. Can you elaborate more on the anomaly detection? Is there a capability in Zepl to automatically highlight the anomalies as soon as the data is loaded? Zach, Taylor? Oh. I think I lost my audio.
Zach, I think you're on mute.
Oh, can you hear me? Can you hear me?
There we go.
I was on mute. Great. Yeah. So as far as identifying anomalies, that's why we have created a lot of the built-in visualizations, and the interactive Plotly editor that I shared with you has a number of different charting libraries built in. So I think that from a visual standpoint, a really great way to start identifying anomalies, like Taylor had shared at the beginning, is within that visualization layer, and starting to have, you asked about, out of the box, can you start to identify these things? Having, not needing to write any code to create a chart that shows you all of your data, and being able to then change that chart between different visualizations is really, really powerful. And I would say, start there. And then ultimately, if there are specific anomalies that you, or specific use cases that you guys are looking to tackle, a lot of the built-in libraries that we were using inside of the notebook that I shared are available to you. And the analysis that we did, is something that you could very quickly spin up and do. And if you have, ultimately, if this is something that you want to explore, I would love to talk to you about it more in detail. I'm not sure who asked the question, but we could get on the phone and talk about the specifics of that use case for you and the company that you work for.
Great.
Yeah, the thing I'll add here is that remember that your data is unique. And this gets to the question earlier about AutoML. It's a very sexy thing to talk about, but in practice, it's not a real thing that's easy to accomplish. Instead, it comes down to running your data as close to your data as you can when you're doing that analysis. It's one where by connecting to Snowflake in a live Zepl notebook, being able to query data as it's coming in allows you to then adapt and manipulate your analysis specific to your data. That's ultimately what data science is about, is it's adapting models to fit whatever your use cases are. So it's where, by having a platform like Zepl and Snowflake, you can really move as close as possible to your data so that you're interacting with it directly. And this is one where, I'm sure any data scientists that are on the call will laugh, all of my data scientists will go do analysis, and they'll create these static matplotlib graphs that I can guarantee you the first time I show that to a stakeholder, they're going to want to see it filtered or interact with it or see a different date range. And that gets really annoying data scientists. So having a platform where you can just call a native visualization that has the standard, interaction tools, date pickers, and all of that, like that really does make a platform like Zepl a lot more approachable for a non-technical person. They don't need to know what's happening with the models or with any analysis that you're doing. Instead, they can interact with just a graph at the end.
Excellent. Well, thank you everybody for attending today, and we would love to keep the conversation going. If you're interested in getting a free POC using anomaly detection on your own data, contact Zach at Zepl.com. Thanks, everybody. Have a great day.